Hello my dear students, in this lecture we are going to see Einstein's mass-energy relation by special theory of relativity. So my dear students, the topic name is mass-energy relation. Therefore write down mass-energy relation or the Einstein's mass-energy relation by special theory of relativity. Now for this special theory of relativity, I will write STR. And we know that, and everyone knows that from the school level, as per Einstein, the mass energy relation is nothing but total energy is nothing but mc square. And in this lecture, our target is to prove this E is equal to mc square. Now, my dear students, let us understand some points regarding this Einstein mass energy relation by special theory of relativity. Now, my dear students, special theory of relativity (STR), special theory of relativity gives universal relationship between mass and energy. This E is equal to mc square is universal relation. This will never change, right? And this is always true. Therefore, this special theory of relativity gives the universal relationship between mass and energy, which is nothing but mass E is equal to mc square. Again, this special theory of relativity removes the distinction between mass and energy and makes it possible to convert one into other. Let us understand the statement. What they are saying, initially, before this relation E is equal to mc square, before this relation, all were assuming that mass and energy are different phenomena. Yes, they are different, but before that, before this derivation, we were assuming, or we are assuming, that energy cannot be converted into mass and mass cannot be converted into energy. But after this special theory of relativity, we can say that they are not different. Energy can be converted into mass and mass can be converted into energy. The same is written in second line. And also, my dear students, the experimental verification of E is equal to mc square has been confirmed in nuclear reactions such as nuclear fission and nuclear fusion. Now, my dear students, in your 12th standard physics, you might have heard about nuclear fission and fusion reaction. Fission means, let us say, you have one larger atom, and this atom, the center of atom is nucleus of that atom, right? And atom is always spherical. Atom is always spherical, like football. And this center is nucleus of atom. Now this nucleus of atom will split into smaller nuclei. This nucleus of atom will split into smaller nuclei. Let us, this is one atom, another atom, another atom. Means here the larger atom is splitting into smaller atom, or the nucleus of atom is splitting into smaller nuclei, is called fission reaction. And during this reaction, large amount of energy is released. And fusion is opposite to this, means smaller atoms will combine together to form a larger atom. The nucleus of atoms will combine together to form a larger atom, is called fusion reaction. And again, in both cases, large amount of nuclear energy is released, right? And this is, in these reactions, it is proven that, experimentally proven that E is equal to mc square is valid. Now, to prove this E is equal to mc square, or to see the derivation of E is equal to mc square, let us consider some things. Now consider a particle of mass m naught. Now here, or m, let us say any mass. Consider a mass m starts moving with velocity v because of application of force. The same is written here. See, later I am directly going to do the derivation. That's why the statement is written here. I am considering one mass, and on this mass the force Ef is acting, and because of this force the mass is moving with velocity v. Now my dear students, again from mechanics we know that there is a work energy principle. That is, because of this force there will be a displacement, and force into displacement is nothing but work, and same work is converted into kinetic energy of the particle. See, when your force is applied, there is a displacement in the particle, and force into displacement is nothing but work done. And when your force is applied, for this mass velocity will be achieved. This mass will gain some velocity, and 1/2 mv square is nothing but kinetic energy. Means work energy principles there says that this work, displacement work, can be converted into kinetic energy. This displacement work is equal to kinetic energy. Now these relations we are going to use, and let us go for the derivation of this E is equal to mc square. Now let us consider, I have one particle, and let us say the particle is having mass m naught, and m naught is nothing but rest mass. When your particle is at rest, then mass is called m naught from the special theory of relativity, right? Later we will use this special theory of relativity. In previous lectures we have seen how to find moving mass and stationary mass. Here also I will tell you, don't worry. Right, now let us say this is a mass which is at rest. Rest means it is having mass m naught, and on this mass if I apply force F, on this mass if I apply force F, because of this force the mass will start moving. Right, the mass will start moving, and let us say the mass is displaced by, I am considering very small displacement in this motion. I am considering very small displacement in this motion. Let us say very small displacement is dx, and now mass is started moving with velocity v. Mass has started moving with velocity v, and when your mass comes in motion, the mass is nothing but m. Right, means here m naught is rest mass. For any object, rest mass is nothing but m naught, and whenever the mass starts moving with velocity v, m is moving mass. Moving mass, right, or relative mass, we can say relative mass also. And my dear students, we have relation between this m and m naught. This m is nothing but moving mass, or whenever object is moving, the mass of object is nothing but rest mass divided by under root of 1 minus v square divided by c square. This relation already we have seen in special theory of relativity. You can go back and watch my this lecture to find this moving mass in terms of rest mass. Right, again here also understand these terms, where m is moving mass, m naught is rest mass, v is velocity of mass, v is velocity at which mass is moving, and c is a velocity of light. Many times in every lecture we have seen this velocity of light as well as this moving velocity. Right, now my dear students, c, remember c is velocity of light, v is a velocity of mass. Right, now again my dear students, see, because of this force there is a very small displacement dx, therefore there will be a very small work done. Now let us say find this work done. Now this work done will be very small, that is dw, right, which will be equal to, work done is always force into displacement na. Work done is nothing but force into displacement. Force into displacement in the direction of force. Force into displacement in the direction of force is nothing but work done. F dx is a work done. And my dear students, we know that as per work energy principle, the work energy principle says, work energy principle from mechanics. In physics 1 you might have seen this work energy principle that you have learned in physics 1. Work energy principle says that the work can be converted into energy and energy can be converted into work. And my dear students, here as it is in motion, during motion, whenever there is a velocity, there is a kinetic energy. Whenever the mass is at rest, there is a potential energy. Whenever mass starts moving, there is a kinetic energy. Means here displacement work means it is a kinetic energy, because displacement means motion, it is a kinetic energy. Therefore this work is again nothing but very small change in kinetic energy. Small change in work is nothing but small change in kinetic energy. Therefore my dear students, as per this work energy principle from the physics 1 or engineering mechanics or mechanics, we can say it is nothing but dw is equal to dke, small change in kinetic energy. Now my dear students, again in Newton's second law of motion, in second law of motion you have seen, second law of motion you have seen, force is nothing but rate of change of momentum. Force F is nothing but rate of change of momentum. Rate of change of momentum is nothing but force, and momentum is nothing but product of mass and velocity. Therefore momentum is generally represented by p. Therefore force is nothing but dp by dt, rate of change of momentum with respect to time. Rate is always with respect to time, right? Change in momentum with respect to time. P is momentum, my dear. Here p is nothing but momentum, and momentum is nothing but it is a product of mass and velocity. It is a product of mass and velocity. Therefore this momentum is nothing but mass into velocity, right? So I hope these are basic things. Now let us replace this force with rate of change of momentum, dp by dt, with dp by dt, right? So note down this everything. Later I need this force equation, this mass equation, this momentum equation, and this work equation. I am going to delete this. Now this work done, very small work done, is nothing but F dx, just now we have seen, and force is nothing but rate of change of momentum. Therefore dp by dt into dx. dp by dt is rate of change of momentum, right? And my dear students, again you have seen one quantity. What is velocity? Velocity is nothing but dx by dt. Change in displacement with respect to time is nothing but velocity. Everyone knows this from the school level. In 9th standard you have studied this, as well as in 10th standard, 11th standard, 12th standard. Everywhere you have seen this. Also in many subjects you will see this. Rate of change in displacement with respect to time. Displacement with respect to time is called velocity. Rate of change of displacement with respect to time is nothing but velocity. Therefore here can I say this dx divided by dt, can I replace with velocity? Therefore my dear students, this work becomes, this dw work becomes dp into v. Therefore again I can write v dp, right? So my dear students, this dw is equal to v dp, change in momentum. But what is momentum? Momentum is product of mass and velocity. Therefore d of mass and velocity, d of mass and velocity, this will be our work, right? Now my dear students, here whenever the object is moving, the mass is changing, this m is variable, as well as if this force is applied, velocity is also variable. As this velocity and mass are variable, therefore here we have to apply UV rule. For this differentiation we have to apply UV rule. And what is the UV rule in mathematics? There is d of uv is nothing but, we are considering u as constant, derivative of v plus v as constant, derivative of u. This is called UV rule in mathematics. Now same UV rule we have to apply here, because during motion mass is changing. Just now we have seen the mass formula in terms of m naught and v and velocity of light, c values. As well as during motion, because of this force, velocity is changing. It is an accelerated motion or not? As there is a force, it is an accelerated motion. Therefore this force will change this velocity. Therefore velocity is also variable. Therefore I can write like dw is equal to v into one time mass constant, derivative of velocity, plus velocity constant, derivative of mass. This is how we can write. So let us simplify again. Therefore dw is equal to, let us multiply with this v inside. Therefore what we will be writing, mv dv plus v square dm. This will be our work equation. Let us name this equation as equation number 1. Now my dear students, here what we have to do, from the theory of relativity, that is special theory of relativity, we have to find mv dv. Now how to find this mv dv? We know that this moving mass is nothing but rest mass, which is always constant, divided by under root of 1 minus v square divided by c square. Now velocity of light, c is always constant, m is always constant, m naught is always constant. Rest mass and velocity of light are always constant. Now from this relation we are going to find mv dv, and we are going to replace here this value. Now to find this, let us square both side. Squaring both side. If I square both side, now what I can write, m square is equal to m naught square divided by, here square root and square will cancel each other, it will become 1 minus v square divided by c square. Again if I multiply this c, cross multiplication, see what we will get, m naught square divided by c square minus v square divided by c square. Now let us take this c square in numerator. Therefore my dear students, this m square is equal to m naught square c square divided by c square minus v square. Again let us multiply this m square by c square minus v square, right? So here I will delete this portion, this side I will delete, because already we have written this. Now my dear students, what I am doing, cross multiplication I am doing again. Therefore what I will get, m square, if I multiply this, m square c square minus m square v square, m square c square minus m square v square is equal to m naught square c square, right? But my dear students, my target was, let us say this is our second equation, but my target is I have to find mv dv, and in this derivation mv dv there is a dv. So to get dv I have to differentiate this equation. So my dear students, let us differentiate this equation. Differentiate equation 2. And we know that here mass is variable, velocity of light is always constant. C is constant, M is variable, V is variable, M naught is also constant. M naught, rest mass, is constant. C is velocity of light, constant. Only variable are M and V. So my dear students, again here this M is variable, C square is constant. Therefore while differentiating, what will be remaining? C square. Derivative of M square is 2M, but M is variable, that's why dm is also will come there. This is simple mathematics. This is straightforward mathematics. As M is variable, 2M dm minus. Now my dear students, here both M and V are variable, therefore we have to go for UV rule. First quantity, first term constant, that is M square constant, derivative of V square. Derivative of V square will become 2V dV, because V is variable na, 2V dV. Then V square is constant plus V square, right? V square will be constant then, and derivative of M square will be 2M dm. Derivative of M square will be 2M dm. 2M dm is equal to, now here both M naught and C are constant, means M naught square C square, this complete term is constant and derivative of constant is 0, therefore is equal to 0. So let us equate both sides. Therefore can I write C square into 2M dm is equal to M square, this term I am taking on complete term on this side, right? Complete term let us take on another side. Therefore what I will get, M square into 2V dV plus V square 2M dm, right? Am I writing correct? Are you getting this point? Now again see here 2M, there is also 2M, there is also 2M. If I divide both side by 2M, both side I will divide with 2M, then equation will become C square dm is equal to, if I divide here with 2M, 1 M will get cancelled, therefore it will remain mv dv plus this 2M will go cancel, V square dm, right? This will be our equation. Now from this equation target was to find mv dv, so let us find this mv dv. Therefore my dear students, this mv dv will become equal to C square dm minus V square dm, right? Or also can be written as this mv dv is equal to C square minus V square dm, right? So let us put this value. What I will do, let us say this is my equation number 3. I will name this equation as 3, because already 2 we have written somewhere, I think already, or let us say it is a equation number, yes, equation number 2 we have written. Let us name this equation as equation number 3 and let us put this 3 in 1. So here this is our third equation and we are putting this third equation in first equation, right? Instead of this mdv we are going to put the third equation. Therefore first equation will become dw is equal to mdv is nothing but C square dm minus V square dm, and then there is already V square dm in equation number 1. See this complete term is nothing but mv dv. Now my dear students, can I say here this V square dm and minus V square dm will get cancel each other, therefore this dw is nothing but C square dm. dw is equal to C square dm. Let us say this is our fourth equation. Now again just now we have seen, see we have one rest mass m naught. Rest means at this location velocity is 0. At this location velocity is 0 means kinetic energy is also 0. If mass is not moving, what is the kinetic energy? 0 only, right? This is rest mass, means this condition is rest. This condition is rest, and at this rest condition if I apply external force, because of this external force this mass will displace some distance, and now moving mass becomes m and velocity here is v. Now at this location velocity is v and it is in motion. Now it is in motion, right? And we have written that this displacement is written dx from m0 to m. This displacement is dx, right? So my dear students, at this location as there is a velocity, there will be a kinetic energy. Let us say this kinetic energy as ke, right? There will be a kinetic energy ke at this location. So my dear students, here and as per work energy principle we can replace this work with the help of kinetic energy. As per work energy principle, this dw can be written as dke, change in kinetic energy, which is nothing but c square dm. Now what I will do, I will integrate both sides by putting the limits. Now here what I will do, integrate both side by substituting the limits. Now see, integration of kinetic energy, change in kinetic energy, integration of change in kinetic energy is equal to integration of c square dm. Now understand, limit understanding is very much important. Kinetic energy is changing from 0 to ke. Initially it is 0, then it is ke. Therefore kinetic energy is changing from 0 to ke. And at the same time, this mass is changing from m0 to m. Change in mass is m0 to m. Right. Therefore, this kinetic energy will become kinetic energy which changes from 0 to ke is equal to c square is always constant. Velocity of light is always constant outside integration. Integration of m is integration of 1 is m, and m changes from m0 to m. Let us put the limits. Therefore, it will become kinetic energy minus 0 is equal to c square m minus m0. So let us multiply this c square inside bracket. Therefore, this kinetic energy will become equal to c square m, or we can write mc square minus m0 c square. This is kinetic energy. My dear student, this is not total energy. This is only kinetic energy. And let us name this equation as equation number 5. This is only kinetic energy. And my dear students, m0 is what? m0 is rest mass or not? m0 is rest mass, and c is velocity of light. Don't worry about that. And whenever mass is at rest, the mass possesses only and only potential energy. Are you understanding this? Whenever mass is at rest, the mass possesses only and only potential energy. Therefore, this quantity, you can say this m0 c square is nothing but potential energy. Right. At rest, m0 is rest mass. Therefore, at rest there is only potential energy. Therefore, here potential energy is nothing but m0 c square. As left side is energy, right side both quantities must be energy. As left side is energy, right side both quantities must be energy, then only unit balance will be there. Right. Therefore, this is potential energy, rest mass potential energy. So let us put this potential energy in the equation number 5. So that's it, my dear students. We have derived the equation. Therefore, kinetic energy is equal to mc square minus potential energy. Let us take potential energy on left side. Therefore, kinetic energy plus potential energy is equal to mc square. And my dear students, the total energy which is represented by E. Total energy is nothing but always it is a summation of all the forms of energy, and here the forms of energy are kinetic energy and potential energy. Total energy is always summation of all the forms of energy, and here the form of energy is motion and rest, that is kinetic energy and potential energy, which is nothing but mc square. Therefore, my dear students, this E is equal to mc square is always valid. Very important relation. And from this relation we can say the energy and mass are convertible. From this equation we can say the energy can be converted into mass, the mass can be converted into energy. Thank you, dear students. In next lecture we are going to start new chapter of this syllabus.